Hi class, today we are talking about section 1.3 complex numbers. We're going to do a really quick review of complex numbers. So just to recall, we have imaginary numbers, which is I. We call I for imaginary, and it's the square root of -1, because I squared makes -1, when typically a real number squared would be positive. That's why this one is imaginary. So what we want to make sure is all of our complex numbers are of the form a plus bi, meaning that they're going to have a real component a and a real coefficient b attached to the I imaginary component. So let's just practice a few questions. Just adding and subtracting. 4 plus 5i plus -8 plus 2i. Basically what you want to do is add the real portions. So we're going to take out the real portions and combine them. And then we're going to take the imaginary portions and combine them. What we're doing is we're adding component-wise. Our real component is -4. And our imaginary is 7i. Alright. The same thing goes for subtraction. But you have to make sure that you take the opposite of the second number. Everything in the parentheses. It almost looks like adding or subtracting a binomial. And in many ways it's the same, because you're going to treat each component separately. So we would say -8 plus 4i. We're going to add the opposite. And so we get -8 minus 2 plus 4i plus 2i. We get -10 plus 6i. Alright, now this is different from question number 4, which you'll see soon. And we're going to talk about those differences, because I see a lot of mistakes happen when we get to questions like number 4 or number 2. Alright, here we've practiced addition, subtraction, and now we're practicing multiplication. We're going to multiply the imaginary times the real, so we're going to get -9i. We just multiplied their coefficients. And we're going to get 3 times 4 is 12, and then we're going to get I squared. Well, this is not in the correct format, so because all the complex form numbers are of this form. So I do need to make sure that's -9i plus 12. I squared turns into -1. And then we're going to say -9i minus 12. It actually isn't in the correct format yet till we put the real number first and then the imaginary number next. And so the A portion is -12, our B portion is -9. I wanted to do question number 4 side by side next to question number 2, because I see a lot of people making mistakes. 5 plus 3i multiplied by 2 minus I. Well, how are we going to do that? Well, right here we have multiplication because we have the parentheses right next to each other, separated by nothing, an imaginary dot. Right here in number 2 we had subtraction because we had the parentheses separated by a subtraction symbol. And for some reason these get mixed up a lot, because we see, oh, you have 2 parentheses, 2 sets of parentheses next to each other, we must be multiplying. And not always the case. If you're separated by a minus sign or by any symbol, you have to respect that and it's no longer multiplication. But when they're separated by nothing, then that is multiplying. And we're going to multiply component wise. So you're going to get 5 times 2 minus I plus 3i times 2 minus I. Here we get 10 minus 5i plus 6i minus 3i squared. That's 10 plus I minus 3, and I squared turns into negative 1. I get 10 plus I plus 3. That becomes 13 plus I. You have to be very careful right at this step that when you convert it, you get to the right sign. So that's, a lot of people will try to do that in their head, but they'll write minus 3 instead of plus 3. So that's just something to be aware of. We're now looking at complex conjugates, and if you recall, a conjugate is it looks like two terms, a binomial, where the sign in the middle is different, but everything else is the same. We're looking at complex conjugates, and basically, if you said a plus bi and a minus bi, those are conjugates of each other. The reason why they're important is because when you multiply conjugates by each other, we get all the middle terms to cancel out. I'm not going to write the whole thing out, but we're going to get a squared minus b squared I squared. And this is important because I squared turns into negative 1. So we can get a squared plus b squared. And notice that when we get that, it's no longer imaginary. It's no longer, it no longer has an imaginary component, so now it's a strictly real number. And so when you take a complex number and you multiply it by its complex conjugate, you can get a real number as a result. We're going to use that skill right here when we're doing number 5 and we're doing division, because division of complex numbers is really difficult. What we're going to do is divide by a real number. How so? We're going to take this denominator and multiply it by its complex conjugate. But in order to not change the value of the fraction, that means I'm also going to multiply the numerator by the same number. So I'm going to do a bunch of multiplication over here. That means for the numerator, I'm going to get 2 plus 2i plus 3i plus 3i squared. For the denominator, I'm going to get 1 plus I minus I squared. Taking that and simplifying it, I get 2 plus 5i plus 3 times negative 1. And I get 1 minus I squared, which is also a negative 1, because those two middle terms cancel out. Alright. Let's simplify a little bit more. I get 2 plus 5i minus 3 over 1 plus 1. And so then I get negative 1 plus 5i over 2. Now this is technically not in the right format because we still want it to be in the format a plus bi. We want to be able to easily identify those portions. So my a is negative 1/2. Then I get plus. My b is 5/2. And then I get I. And this is a better formatting of my answer because this is a complex number. We're now going to be solving quadratic equations with complex numbers. These were equations that previously we might have said were prime, or that they had no real solution. And that's still true. They have no real solution because their solution might have imaginary components. So something like this, where it's not the difference of squares, but it's the sum of squares. I'm going to go ahead and solve this using the square root method. I'm going to do that my first step by subtracting 25 from both sides and moving it away from the x squared. And normally when you look at a question like this, you'd say, well, we can't have an x squared equal to a negative number. That doesn't work. However, now that we know how to do complex numbers, we can. So we're going to square root both sides, add the plus and minus symbol in. And I'm going to get x is equal to the plus and minus of the square root of negative 1 and the square root of 25. So that would be 5i. So now I have two solutions. It doesn't look like two solutions, but alternatively you could write them as two solutions, as negative 5i and positive 5i. It just saves some time if you write them in the same plus or minus symbol. Okay, when we look at questions that have quadratic equations in them, we actually don't really know if the answer is going to have a complex number or not. We just need to approach it like the other ones. So as you can see, I'm subtracting the 2x from both sides. And I have this equation that I'm going to try to factor as my first step. But if I can't factor, then I can try to complete the square or use the quadratic formula. So I'm going to say my a is equal to 5. My b is equal to negative 2. My c is equal to 1. And that's going to be x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're just going to simplify this until we get to something. That becomes a positive 2 plus or minus the square root of 4 minus 20 all over 10. That becomes 2 plus or minus the square root of negative 16. And notice that inside my radical I have a negative. So that becomes 2 plus or minus 4i. And that's my clue that I have a complex number as my answer. It happens because the radical has a negative inside of it. Now we can simplify this, so we're going to write x is equal to 2 times 1 plus or minus 2i over 2 times 5. Crossing those 2's off, I get x is equal to 1 plus or minus 2i over 5. Once again, we want to write it in the format 1 over 5 plus or minus 2 over 5i, because that is the correct format to put our complex numbers in. So you don't want to write them as fractions over a real number. You want to write two fractions as each of those being the a and the b portion.